The rest of the course is going to be about sequences and series. In this video, we're just going to be giving an introduction to what those things are. A sequence is simply a list of numbers. If I have this list of numbers, 0, 1 minus a half, 1 minus a third, 1 minus a quarter, it's a list of numbers, so it's a sequence. I can think about what would happen to these terms over time. So this is 1 minus something, 1 minus something smaller, 1 minus something smaller. And so over time, I can see that these get closer and closer to 1 minus 0, also known as 1. By contrast, a series is a sum of numbers. So instead of just listing these, I can add them up. I can take my first number and add it to my second number, and add that to my third number, and add that to my fourth number, and so on. I can also think about what this number is approaching. So I keep adding and keep adding and keep adding, and the numbers I'm adding are changing, but they're getting pretty close to 1. So after a point, I'm basically adding 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. So this sum just grows without bound. It's not getting closer and closer to some number. Depending on your application, sometimes it makes sense to add up a sequence and turn it into a series, and sometimes it doesn't. Sometimes you just want to keep a list as a list. Let's visualize these in another way. I'm going to have a list of numbers. On the left, they're just going to be listed one after the other. That's the sequence. And on the right, they're going to be added up. So my first number is 0. My second number is a half. My third number is 2/3. My fourth number is 3/4. And my fifth number is 4/5. On the left, we're considering every number on its own as its own thing. On the right, we're adding them up, adding them all together one after the other. Here's another famous visualization of sequences and series. We're starting with a square, and that square has area 1. And I'm going to put different sized tiles on the square, and each time it's going to cover half of the remaining area. So my first tile is a tile that is this size and shape. If the whole square has area 1, this first tile has area 1/2. My second tile is half of what's left over, so half of a half. This has area 1/4. And now altogether, 3/4 of my square has been tiled. I can keep going like this. The next tile has area 1/8. The next tile has area 1/16. The next tile has area 1/32. And as I go on, I can think about my tile sizes and my covered area separately. Let's start by just thinking about the sizes of the tiles. We'll think about the covered area later. This is a list of numbers. It tells me how big is my first tile, how big is my second tile, how big is my third tile. I can think about what happens over time. As I go down the list, my tiles are getting smaller and smaller and smaller. So I can say this list approaches 0. Because it's a list, we call this a sequence, not a series. Now let's think about the second criterion. We're thinking about how much area has been covered. At first, we put down one tile and we'd covered half the total area. Then we put down a second tile and we'd covered 3/4 of the total area. Then we put down a third tile and we'd covered 7/8 of the total area, and so on. And as we put down more and more tiles, the amount of area that's being covered is getting closer and closer to the entire area, which was 1. So this covered area is a sum of numbers, not a list of numbers. It's approaching 1. Since it's a sum, not a list, this is what we call a series. One thing to notice is the same collection of numbers goes into the series and the sequence. The limit is different. The size of my tiles is going to 0. The total amount of area covered by all my tiles put together is going to 1.